Hey y'all, in this video I'm going to show you how to use Molecular Workbench in a couple of simulations that are included in Molecular Workbench. And so the first step is to actually go to the website and download the software. And so what I'm going to do is click on the link provided under the Try Simulations page, make sure I hold down Control so it'll take me to another page. And it'll take me to this website here, which is Install Molecular Workbench. And if I have Windows, I do install Molecular Workbench. If I don't have Java yet, then I have to install Java first and then Molecular Workbench, or the Mac is just one step. You click a link and then you can download it right away. Now once the application is downloaded, I can install it on the computer, no problem. It'll take you through the wizard to do that. Now I already have it downloaded, so I'm going to pull that up. Now once I'm on my home screen, what I want to do is I want to click on Browse Entire Library, and under that I will go to Heat Transfer. And under heat transfer, I'm going to use two things. I'm going to use smoke in the wind, and I'm going to use comparing thermal conductivities. So the first thing I'll do is I'll do the comparing thermal conductivities simulation. Once I click on that, it'll take me to this screen here. Now the most important thing here is to make sure that you show your isotherms. I'm going to click on Show Isotherms, and then I can just run my simulation regularly, and you can see that these lines here are the isotherms, and obviously the heat lines. You can show the heat flux lines, but you know that the heat flux lines are basically going to run perpendicular to the isotherm lines. And let me show you a couple other neat features with this simulation. I have it paused right now. I'm going to reset it, and a couple of things. You can obviously show heat flux lines. I can change the conductivity of the left rectangle here by messing with this. I can have it, let's just keep it here where it is. Another neat thing is I can move the thermometers around wherever I want them to be. There's a timestamp here that shows progression over time. The best thing here is you know that this is the conductivity, the left rectangle is the conductor. So I can kind of move that around, and it'll change the isotherms and the heat flow accordingly, and it'll change the temperature down here accordingly, so the students can really see how the conductor affects the heat flow. So let's run it really quickly. I'm showing my heat flow lines, I'm showing my isotherms. Let me take off the heat flux so you guys can see this a little bit better. But let's say I move this here. I know that my isotherms are going to move well toward the right, causing the temperature down here to increase pretty steadily. Now, if I move my conductor down here, I know that, one more time, my heat flow lines are going to go from left to right, because that's what the conductor is going to do. But anyway, you can have your students mess around with any of these features to kind of build a profound definition of what conductivity is. Now the second simulation we're going to do is the smoke in the wind simulation. So what I'm going to do is I'm going to click back, and it's going to take me back to this page, and then I'll click on smoke in the wind. And smoke in the wind has very similar features that you can move around as well. So here's some of the features of smoke in the wind. I have initial heat source here that I can move around wherever I really want, but I'll leave that be. Really what you want to mess around with is thermometers. So that's probably a good way if you want to show convection and rotation of the smoke. And I can go ahead and run this. I will keep the kinematic viscosity around the same. And you can show isotherms, you can show streamlines. If I show you the isotherms, it's a little more complicated with the single source, but as they spread out over time, it's easier to see, and I can show streamlines, of course, the way that the heat's flowing, and I can make my temperature source a lot hotter, and then my thermometers will track temperature over time. And so basically students should get an idea of what convection looks like. You know that it's coming from a single source, and so as this zone heats up, my streamlines show that that heat will go down toward this way. It'll go toward the bottom as it cools down, and so the streamlines match up with the temperature changes over time. I would leave the fan alone, because you can see that if I move the fan, you're going to end up getting all kinds of crazy stuff going on. I mean, I guess you could exclude this section here by moving the fan up forward, but for middle school's sake, it's okay to leave the fan exactly where it is. And eventually over time the fan will cause a fatal error, which you just saw.